Hi everyone, in today's lesson we're going to talk about operations with matrices. So adding and subtracting matrices are actually really simple. There's a couple things though that you need to keep in mind. The sum and difference of two matrices of the same size is a matrix with elements that are the sums or differences of the corresponding elements of the two given matrices. So the key in that statement is same size and corresponding elements. So what do I mean by same size? They need to have the same number of rows and the same number of columns. So if you take a look here, there are two rows and 1, 2, 3 columns. Same thing here, two rows, 1, 2, 3 columns. So if you need to write down that rows are left and right and columns are up and down. So this first pair of matrices we can add together because they have the same size. So what we're going to do is plain and simple. We're going to add first with first. So this guy with this guy. And then we're going to do this one with this one, this one with this one, this one with this one, and so on and so on. I'm running out of colors here, but I can just go and repeat the colors. But we're going to go each corresponding element. So why don't you take a minute and add 2 and 3, -3 and 1, 0 and 2, and make yourself a new matrix and hit resume when you're ready for the answer. Okay, so the first one I did 2 and 3 is 5. -3 plus 1 is -2. 0 plus 2 is 2. 1 plus -3 is -2. 2 plus 2 is 4. And -5 plus 5 is 0. So it seems pretty simple. Now, how can I make this a little bit harder? Well, I could ask you to add matrices that only have letters. Now, we would do same thing as we did before, first with first. So A plus W. Now, you technically can't add those because they're not like terms. So you would just write this as A plus W. Then the next term would be B and X. So again, can't add those. So the next term would be B plus X. And then so on and so on. My next term here is C plus Y, so we'll call that C plus Y. And then we have D and Z. Those can just add to D plus Z. And that is my simple matrix. So why don't you take a minute, pause the video, and then try example number 3 here, and then hit resume when you're ready for the answer. Okay, so subtraction works the same way, but you just have to be careful if there's double negatives. So I'm going to do 3 minus -2. So that's a double negative. So this is really saying 3 plus 2, which is 5. Then I have -2 minus 2, which is -4. Then I have 5 minus 3, which is 2. And 0 minus 4, which is -4. Now, what you should notice about this last one is that these matrices are not the same size. This has 1, 2, 3 rows and 2 columns, and this only has 2 rows and 3 columns. So this one is actually not possible. And the reason why is because this we call a 3 by 2 matrix. 3 rows, rows come first, rows, 3 rows by 2 columns. And then this is a 2 row by 3 column. They're not the same, so we're not able to do that. So feel free to write that rows come first, then columns. Okay, next, multiplying matrices by a scale factor. So this number here in front is called a scale factor, and I'm multiplying it by all of the elements in here. So what you're going to do is multiply the -2 by 3, -2 by -2. Multiply the -2 by every single piece in here, and that's your new matrix. So why don't you take a minute, pause the video, try it on your own, and then hit resume when you're ready for the answer. Okay, so -2 times 3 was -6. Then I got +4, 0, 2, -2, 2, 0, -6, and 4. That should be your final answer. Okay, let's go on to the back now. So the harder type of multiplication is not scalar multiplication, it's matrix multiplication, where I'm, for example, taking one matrix and multiplying it by another. So in order to do matrix multiplication, we must check the size of the matrix before we start. So what needs to be happening here is that the amount of columns in the first matrix needs to be the same number as rows as the second matrix. So remember, it goes rows and then columns. So this column has to be the same as this row. So the way that I like to do this to prove to see if we can do them is we first look at the matrix. So let's look at this one, for example. It has 1, 2, 3 rows and 2 columns. So we're going to say this is a 3 row by 2 column. And I want to multiply this by a 2 row and 2 column. So we actually are able to do that. Why? Because this column, when multiplied, is the same as these rows, right? This 2 and this 2. So basically, you're just looking for these two pieces to be the same. And because they're the same, our resulting matrix will be a 3 by 2. Basically, these are going to be crossed off, and your resulting matrix will be a 3 by 2. So let's just do that for all of these here. So this is a 1, 2 row by 3 column. And then this is a 1, 2, 3 rows by 2 columns. So again, they're middle ones, these 3's are the same. So we can basically cross those off, and my final answer will be a 2 by 2 matrix. Let's put our final answer here, should be a 3 by 2. Let's keep going and practice. So let's look at this one. This is a 1, 2, 3 rows by 1 column. So this is a 3 by 1. And this is a 1 row by 2 column. So that's going to work. These two again cross, so my final answer will be a 3 by 2 matrix. And then let's check this one. We've got 1, 2 rows, 1, 2, 3 columns. And this one's got 1, 2 rows by 1, 2, 3 columns. So we've got a problem. These two are not the same. Therefore, this is not possible, since this one and this one are not the same. Okay, so now that we know when we can multiply matrices and when we can't, I think now is a good time to stop the lesson. And I'm actually going to show you this matrix multiplication in class tomorrow, but these are the prerequisite skills that we need in order to be successful. So if you have any questions on this stuff, now is a good time to jot it down. Otherwise, I'll see you guys in class tomorrow. Thanks. Have a good night.